So the first thing we need to do to solve this problem is list down what is it we need to find, and in this particular problem we need to find the function of velocity in terms of m1, m2, g, d, and mu. You've probably seen this in math class already where you have a function of x, a function of x and y. But for this problem, it's want you to have a function of m1, m2, g, d, and mu. I put a question mark here. So what is given to us? Well, it's saying that the variable that's given to us is m1, m2, g, d, and I forgot to list mu here. Mu is also given to us in the problem. Oh, right there. So let's see here. We need to draw the free body diagram first. As you can see here, I have drawing it for mass 1. Mass 1, you will notice that it's resting on the surface right here. It's moving to the right, so therefore there's a tension force. I put that T, and because moved to the right, there's a friction force moved to the left, so I label that F of F for frictions. And the weight is M1G, and of course there's a normal force pointing perpendicular to the surface. And the magnitude of the normal force equal to the magnitude of the weight. Otherwise, the object will accelerate either up or through the surface. It has to equal each other for it to not do that. Let's moving on to drawing a free body diagram of mass 2. So mass 2, we have the weight, again, m2g, and we have a tension force is going upward. Okay, that's a free body diagrams of the two masses. So we're going to begin by writing the equations, Newton's law again. We use that to solve various problems. So in this one, we're going to say, I'm going to write the equations for Newton's second law for the first mass. And as you can see, mass 1, force of mass 1 in x directions is equal to mass 1 accelerating. Okay, and so we can break that up even more. We know that there's T right here minus the friction force, which is mu times n. That's the definition of friction. And again, I'm not being very specific with is it a static mu or is it kinetic mu. In this problems, it doesn't really matter. Okay, I just say mu. Expand that even more, and so normal force equals m1g. That's the normal force. That magnitude is equal to m1g and equal to m1a. Okay, mass 1 accelerating. So I'm done with writing the Newton's second law for the first mass. Let's do it for the second mass. In the second mass, we have the same thing. We say that mass, the force of mass 2, or the net force of mass 2, in the y direction is equal to m2 acceleration. Okay. The question is, why is it that I didn't say a1 or a2? Why didn't I say this is a1 and this is a2? The reason for that, because the masses are connected by one rope, so therefore we're going to travel, we're going to accelerate the same amount. So I'm keeping the variable the same. So I'm going to expand that. M2G downward is positive. The reason for that, because we're moving right is positive, so therefore this mass going this way is also positive. And so minus T is the tension going upward. Let's see what's next. So here's just some mathematic trick. I just take the equation from mass 1, I add that to the equation of mass 2. The reason I'm doing that, because if you add them together, the tension will disappear. The tension will go away. The only thing I need to worry about is figure out is the accelerations. So let's add that together and see what happened here. So you have T plus minus T, that's equal to 0. So minus mu m1g is plus 0 is equal to itself. And m2g plus 0 again is equal to itself. And that minus T disappear already. Over to the right side, we have m1a and m2a. When you add together, it's equal to that. So now let's just clean up the algebra a little bit here. I pull out the a, and then I need to, let's just put up there for some room. I divide both sides by m1 plus m2. That will give me equal to a. And of course, if you want to, you can clean it up even more by pulling out g. If you pull out the g, it just looks nicer. Is it wrong if you keep it like this? It's fine. Okay, it's not wrong, but you can pull out the g and do that. So what is next? The next step is say, okay, I found the accelerations. So once you find the accelerations, it's always good to go into the kinematic equation that you have learned. There are two very important ones. This right here is one of the kinematic equations. The derivation of that is also in my other video. you should find that derivation somewhere on top if you're interested in the way how I get this equation. So with this, we need to find velocity, right? And so I'm going to simplify that. I square root both sides, then that would leave me to v by just v. And then I know that the starting velocity is 0. And so a, 2 is that 2 right here. And a is this whole thing right here. I put that whole thing in for a right here. And delta x is nothing more than the distance, so that's a variable d that's given to me. As you can see here, I have velocity equations in terms of chi, in terms of m2, m1, mu, and d. So I have accomplished everything that it is asking me to do, and that's how you do this problem. I will see you in the next video. See ya!